Hey guys, good evening. I hope I'm pretty much audible. Great. A warm welcome to all of you present in our discussion today. Right, so if you've started joining in, just drop a hi or hello in the chat. That'll be really good. And as always, I'll be monitoring my chat, so we'll come back to your queries, concerns, if you have any from any part of our discussion. Maybe, I mean, even from the previous one, or if you won't have anything, if you have anything from anywhere apart from Python as well regarding your career, regarding your job, so we can take that. Hey Narendra Reddy, good evening. Thank you for joining in. Right. So, guys, we'll be talking about our NLP functions today. So, we have been discussing about quite a lot of interesting things in NLP. We discussed about tokenization. We discussed about my stemming, lemmatization, my part of speech, the word nets, the synonyms, antonyms, right? Synsets, uh, right? I think we are left with a couple of more topics. So I believe we are left with vectorization. We are left with parsing. So that's one of the very important topics, parsing. So, right, so we're going to finish all of these today, and then maybe we're going to proceed with a live demo if time permits today, or let's do that tomorrow. Maybe we'll solve one live problem altogether. We'll stitch that all the things which we have studied. Right. So again, before proceeding further, guys, if anybody has any queries, any concerns regarding anything from whatsoever we have discussed so far, do let me know. So we'll take up your queries and we'll try to come back to that as time permits and as we come across your queries, right? So, but before proceeding further, as always, let's start with the round of introduction. So, as you know, my name is Arpit Jain, and I'm a senior data scientist myself. I've been into industry for almost 9 years now, and I've been part with multiple domains. So, I was in a bank earlier, so and then I moved to automobile cloud domain. Then I was in a manufacturing sector. Then right now I'm in a telecommunication domain. So I've seen the industry. I've seen how the data behaves for multiple domains across, and then how we can leverage that knowledge and for our industrial benefits. And along with that, I'm also a motivational speaker, guys. So I take career mentorships. I talk to students regarding the careers. I take industry sessions. So again, if anybody has any concerns regarding their job or anything, so do feel free to put up your questions, so we can always take up your questions. As part of our subjects, we'll be talking about Python, SQL, and data science. So we already started Python, I think, about a couple of months back. So we are now solving the live problems on HackerRank and Lead Codes. So that's what we are doing now in Python. SQL, we already started, I think, a month and a half back, and we have finished all the concepts. And then now we are again solving the live questions, practicing as much as we can from the Lead Code and the hacker ranks and all that. And the data science, we started with visualization, so we finished visualization, and now we are into data science on natural language processing. So we'll be finishing the natural language processing maybe by tomorrow max. Right, so that's what we are doing. Okay, well, before proceeding, let's have a question. So Narendra has a question. Let's see that. He says my background is mobile testing. Okay, my plan is to move my career in ML and data science. Okay, need a guidance. Learning Python courses online, having code knowledge in CZ. See, that's great. Okay, Narendra. So you always be assured of what is the requirement in data science. So there are 4 mandatory skill sets for you. Okay, statistics, machine learning, Python, and SQL. Okay, so Python is one of the 4 legs of a chair for your data science job, basically, right? So with only Python, you cannot get a data science job, and with only SQL, you cannot get a job. So you have to be sure that all the 4 skill sets are equally covered. So statistics, machine learning, Python, and SQL, they all are equally important. Okay. So yeah, if you're going with the Python course, definitely well and good enough. So please be good in Python. Along with that, you also have to work on stats, ML, and SQL as well, right? So I think anyway, Python, SQL we are also covering, so you can go with the practice sessions if you are okay with the basics. But again, if you need the basics, you can always go through the basic sessions also. But apart from that, be rest assured that stats and ML are also equally important, right? So you can always go with the available courses online or howsoever you're comfortable, but both these two are also equally important. Okay. That's great. Again, if I answered your question, that's fine. Again, if you have any other question, Narendra, please put up your query. So we'll take that. So not a problem. Right. So again, coming back, so guys, you have a code right in front of your screen, which is Python 10, right? So with the code Python 10, you're gonna get a bonus Relevel sample test paper, right? So as always, guys, it's a mandatory promotion. Please bear with me for this. So yeah, many a times candidates do miss out on the great opportunities due to multiple reasons, right? So it could be like they don't have a better degree, or they might be having a poor networking, right? So they don't know the right set of people to talk to, basically, to get a job. And also, they don't have a degree from a tier A university, so which is the reason they're not getting the shortlistings done. Very practical problem. And also the resumes with which the candidates are applying, right? So it's not getting shortlisted. So basically, there is some issue in the resume, which is you might be missing some of the keywords, or there is something which is totally beyond your control. So that could be one of the reasons you're not getting shortlisted. And also, you're applying to n number of jobs, but still not getting even a single interview call, right? So very practical problem, but it's a very common problem with almost everyone. And to cater these only, guys, Relevel has been introduced. It's one of the India's first test hiring platform by Unacademy, which is helping you to get your dream job, right? So here you're purely based on your skills and talent, and nothing on sort of any degree or any people networking, right? So if you're skilled enough, if you're knowledgeable enough, you will be getting your job. So here how it works, it's more of an assessment platform, it's more of a testing platform, right? So you'll be asked to go through an assessment, and the only expectation from you would be to get the best score out of these, right? So that's the only expectation from you, right? So if you're, if you're skilled enough, if you're knowledgeable enough, you will be getting the best score, and the only based on this score, the companies will be reaching out to you. So that's how plain simple it is, right? Again, there are certain other benefits involved if you participate in this Relevel testing platform, guys. So at least 50 plus companies, including the top startups and even the unicorns, they are hiring directly from this Relevel platform, right? And the companies include ENY, Upgrad, Cred, Razorpay, Urban Company, and many more, right? So they have the tie-ups from the Relevel platform, and they are hiring directly from Relevel. And at least 1,000 plus open job positions right now, right? So across three different main portfolios, so business development, front end, and the back end development, and multiple sub roles available within these, right? This is completely online again, so you can take this from the comfort of your home. So you're not supposed to be physically present anywhere to be part of this test. You can take this totally from the comfort of your home, right? And also the best part is, guys, this is completely free, so you're not paying even a single penny to attempt this test. So this is completely free, so you're not expected to pay any to shell out any money to be part of this test, basically, right? The only expectation here here is it involves multiple rounds of coding, multiple rounds basically. So you have I mean, you have to finish your entire test in a single day, right? And that day could be of your choice, right? And then post your day examination, right? So your Relevel score will be revealed in a week's time, right? And since it's an assessment, so you know that, so there will be qualifying criteria for you. So you have to score at least 70% to make your Relevel profile. But in any unfortunate situation, if you're unable to score 70%, you always have an opportunity to reattempt this test, but that can happen only after 30 days of your first attempt, right? So always be mindful of that, right? And then there are certain other goodies also, like if you are one of the top scorers in any particular category, right? So you will be awarded with some exciting goodies like a MacBook, iPhone, and something like that. So you can always be watchful of that. So with this Relevel, guys, you are in a unique position to invite interest from the companies instead of you hunting for your own opportunities, right? So it's more like once you have given the test, let's sit back and relax. The companies will start reaching out to you, like post your scores are revealed in a week's time. So That's how it works, right? Registration is also quite easy, guys. So the link is there in the YouTube description, so you can go through that link. And the very first thing you'll be asked to choose the test of your choice, right? So as I said, there will be three different portfolios for you. So business development, front end, and the back end development. Multiple roles, as in, so in the business development, there will be roles like sales associate, relationship manager, customer engagement associate. In the front end, it would be like Angular developer, web developer. For the back end, it would be like back end engineer, data engineer, right? So multiple sub roles. So if you feel that you have your interest in any of such fields and you feel that you are willing to be part of such portfolios, right? So you can always choose the respective test depending on your interest and your skill set. And then the next thing would be to book your slots. So basically book your date for your assessment, right? So the slots are limited. It's a beta platform, so you can always book it fast because slots are limited. The last thing would be to fill up your demographics, like fill up your basic demographic details, as in full name, email ID, birth year, current state, along with your gender. And at last, you have an option of promo code, right? So in this promo code, you can always use the code Python 10. So if you're gonna use the code Python 10, you're gonna get a free Relevel sample test paper, right? So you're gonna get a free Relevel sample test paper for you. So do not forget to use the code Python 10 here, guys. So now if you have used the code Python 10, so this is how your dashboard should look like. So this is where you have the option of a practice tab. So in this practice tab, you can see an option of a sample paper. So with this sample paper, basically you can download this paper and you'll be having the similar sets of questions which you can expect from the actual Relevel tests, right? So this is an ideal way from where you can be mentally prepared for the test you want to be part of, right? So be mindful of that again. With this, guys, I would definitely recommend you to at least register for the platform. So there is no harm in doing that. So it's anyway completely free, right? So you're not paying even a single penny to be part of this test. So you can always try it once. So if you feel that you're not getting benefited, you can always take your decisions elsewise later, but at least you can try it for once. Right, so that's my recommendation. Again, guys, you know we have an official Telegram channel as well. So this official Telegram channel, again, the link is there in the YouTube description. So do not forget to join this channel. It's a one-place stop for you for all of your queries, right? So you can be part of this channel, and all the latest streams, latest schedules will be floated around on this channel itself. So you won't be running around here and there for the upcoming schedule, classes, changes, and all that. So there's a one-place stop for you. Right? So do join this channel as well. So at last, I would always recommend you to at least like the video and share it with your friends if you feel that you're getting benefited. So that's the least I can expect from you, right? So do like the video, please. So right, so with this we are into our content slide. So we'll be talking about my NLP functions. So I hope people were following up with what we were discussing yesterday, right? So I hope that made sense. So with this, I'm gonna jump to my browser. So let me just open that. Just a minute. Right, so my screen is visible. Right. So I got an offline request that people were not able to understand, follow up the POS tagging, right? So yeah, so I mean that's fine. I understand it's bit tricky. So maybe we'll take that POS tagging again. So I got an offline request that POS tagging was people were not able to follow it very clearly. So that's fine. That I understand POS tagging is a bit tricky. So we have to understand the various ways we can do the POS tagging and how we can evaluate the taggers specifically, right? And why it is important, right? So it's fine. So we'll start with the POS tagging for today, and then we'll finish up the parsing, and then we end up on the vectorization, right? So that will be the end of our discussion for the functions today. Fine. Anybody has any other questions apart from POS tagging? So that I got it offline. So anybody has any questions on from anything what we have discussed so far, and people are able to follow, right? Cool. Fair enough. Let's proceed then. So let's start with the POS tagging. Cool. So what is POS tagging, guys? So as I was explaining, so basically here what we are trying to do is we have the tags with us. So we have the tokens with us, right? And what are tokens? The individual smaller chunks of my information. So if it's a sentence, my tokens are my words, right? And then if we have a paragraph, my tokens are my sentences. And internally to sentences, the tokens would be words, right? So for each of these words, I'm going to assign a tag. And what is that tag? Basically a grammatical representation of my part of speech, right? So you know about the part of speech in grammar. So something called as nouns, verbs, adjectives, adverbs, pronouns, conjunctions, right? So these parts of speech, which is already by default available in the dictionary, right? So I'm gonna assign that part of speech, basically the tag, to my tokens. And what are my tokens? My individual words here, right? So that is where it's called as part of speech tagging. So I'm tagging the part of speech to my individual tokens. So this is how simple part of speech definition is, right? And why do we need that? So here we talk about four processes in NLP techniques, right? The first is the morphological process, where we, kind of breaks up my the larger pieces of information into smaller pieces called as tokens. That's my morphological process. Then we talked about semantic, synthetic, and pragmatic, right? So here we are trying to make sense of individual words, how they are individually connected to each other. So how basically my two different tokens are connected. So that's why the part of speech is needed. So, and how exactly this is being resulting in the output, right? So whenever we apply a POS tag, right? So this will gonna result in a form of a tuple. And we already learned about tuple in Python, right? So what is a tuple? Immutable form of a collection. So here the tuple would be having two components, the two elements of the tuple. So whenever we apply a POS tag for each word, so the tuple will be resulting of that particular token or the word, along with that the tag. So tag basically here the shorter notation of my parts of speeches, and that part of speeches could be either noun, verb, adverbs, adjectives, or whatsoever, right? So this is how my part of speech works. So I hope this is making sense to people, right? So again, guys, please stop me. So if you're not able to follow up. Okay, so there are multiple tagging lists available with POS tagger, right? So part of speech, there are multiple such tagging available. You can see the entire exhaustive list. So I have already mentioned, try to mention like almost everything to the best of my knowledge. So you can see here we have something called as JJ adjective, right? So and then we have a comparative adjective. So JJ, JJR, and JJS. So JJR is for comparative adjective and JJS is for superlative adjective. And likewise we have for noun, for singular and plural. We have a proper noun, and then we have what, personal pronoun. We have adverb. We have adverb comparative and superlative like this. And then we have to. We have verb past tense, right? So all of the I would say frequently used parts of speeches are already available with us, right? So this is where all of these are with us, and it's been given in this POS tagging list, right? So this is all my the tags. So basically CD or DT or FW or JJ. So this is my tags specifically, right? So now look at this, how we gonna implement it. So the POS tag, the function, it's called as POS tag. You can see this is the function name, basically the POS tag. So POS tag is by default available in my NLTK package. Okay. So and then how we gonna implement this? So basically here I'm gonna pass the POS tag on top of my tokens, right? So definitely I'll be passing the POS tag on top of my tokens, right? Because tokens is my first step anyway for any of my data processing work in NLP, right? So that's my first step of morphological processing. So what I've done here is I have taken a sentence which is like I'm going to school. This is my sample sentence, right? And first I'm gonna tokenize it because that's my very first step, guys. So anything which you do on top of that, like semantic, syntactic, it's working on tokens, right? So tokenization my first step anyway. So now first I'm gonna tokenize this data. So basically converting this entire thing into the individual tokens or the words. And now on top of those words, I'm going to apply the POS tag, which is part of my NLTK package. Cool. So this is how my output looks like, which is nothing but my list of tuples, right? So here, can you see this? So all of the individual tokens, like I is a token, am is another token, then going to school, right? So all the individual tokens are given a different set of tuple. So I is coming here, am is coming here, then going is coming here. And then each of the tuples is having also a second element, which is nothing but my tag of that particular token. So this I is basically PRP. And what is PRP? We have a reference here, personal pronoun, right? So you can see this. So I is basically a personal pronoun. Likewise, am is VBP. What is VBP? Is verb singular present. Present tense in singular, singular present for verb form, right? Then the going, and then to, then school. So basically all of these individual tokens are now assigned the grammatical parts of speeches. Cool? Interesting, guys? Making sense? So this is how my taggers work. This is what my POS tagging is, right? So this is the core concept of my POS tagging. Now the thing is, there are multiple ways, actually multiple way we can look at this tagging. So maybe we can have a default tag instead of a function which is assigning a POS tag. I can use a default tagger. Maybe I can say that all of the words which is part of my available information is a noun or maybe a verb, right? Or maybe I can use two different words together and try to identify the tags. Or maybe I can try to see each word singularly and try to see the tag. Or maybe I can just try to do a trigram. So maybe I try to see three words together and try to see what would be the tagging for that particular combination of three words, right? So multiple ways where we can tokenize this. So that's where multiple things comes into picture, right? So here, look at this. So the baseline of any POS tagging is basically a default tagging, right? So the POS tagging is basically where I'm going to talk about my actual default taggers. So here basically I'm talking about, instead of machine assigning the tags, I'm going to say that now each of these individual tokens belonging to a particular tag category, right? So here what I've done is just to look at this. I'll come to the accuracy part later, but look at this for now. Okay, so what does it say here in the default tagger, which is being imported from the NLTK package? Here I'm going to use the default tagger as NN. So basically what I'm trying to do is I'm going to say that whatever follows in this function, which is my say this expression tagger, in this what I'm going to say that my default tagger is noun, right? So singular noun. So I'm going to say that, hey, please assign whatever follows after this tagging technique. It should be given the tag as noun. Make sense? Okay, so we have a question from Sai, which is, Arpit, should I have a grip over machine learning and AI things to learn NLP, or is understanding of them good to learn NLP? Okay, should I have a grip over machine learning and AI things to learn NLP? Okay, I got a question. Okay, great. So technically, no. Okay, so I'll tell you what is the difference between machine learning, AI, and NLP. Okay, so do not get confused by these jargons. Okay, see again. Look at the data science first. Okay, data science kya hai? Data science is more of I would say a kind of a technique or more of a science in which you are using your knowledge to work on data and get the meaningful business output from that, right? So understanding of your data is like data science of data, right? So that's what it is, right? So in data science, there are multiple, I would say, so data science is a bigger umbrella basically, okay? So data science is a bigger umbrella. And then it comes, so in data science comes AI, right? So artificial intelligence. Artificial intelligence is basically of two types, like narrow and the wide. So I mean the strong AI and the shallow AI basically, right? So strong and the weak AI. So strong AI where we talk about the robotics, right? So the actual robotics. So we have an open world. We talk about the expressions. It's like a robotic engineering. So that's called a strong AI, okay? And then we have a concept of a weak AI. So where we are confining to a particular objective. Like for example, I'm talking about say text, say classification or a regression, right? So I'm specifying that, okay, do only this, nothing else, right? So my weak AI is where my machine learning falls into place. Okay, so AI is a bigger umbrella. Okay, and under AI there is a sub branch, so which is falling under is like the weak AI part. In the weak AI, we have the machine learning. Okay, so in this machine learning now, so I have something called as, so now I have a smaller umbrella now, which is machine learning, which is part of my AI, right? You understood that part. So in this machine learning, we are doing some sort of work. So basically trying to solve some problem statements, right? So now in this case, this problem statement, again, it's all the data problems, right? So this data could be the structured data or the unstructured data, or could be any data, right? So here again in the machine learning, we have another subfield called as deep learning. Okay, so deep learning is a sub branch of my machine learning. So in machine learning, we have the problems which is for the structured data called as regression, like continuous numbers and classifications and clustering and all that. So that's part of my standard techniques, standard on the structured data. Okay, so I have a tabular format of a data, but something which is not structured, right? So something which is like a text, or something which is like an audio, or a video, or an image, right? So for all these kind of not structured data, we have another techniques, which is an advanced technique called as which is following up certain algorithms. So machine learning is what? A certain set of rules, or certain set of algorithms through which you're solving the data problems, right? So the standard algorithms, standard rules are for the continuous variables, or the where I have the standard data. But for this set of unstructured data, we have certain another rules, another set of algorithms, right? There, and those set of algorithms are clubbed under deep learning. So deep learning is basically a sub branch of my ML, machine learning only. Okay, it's not a fancy thing. Okay, and in this deep learning, there are multiple subfields, right? So deep learning, may you'll be doing the image ka work, you'll be doing some video analytics, you'll be doing something on text, and that's where NLP comes, right? So NLP is again one of the fields of deep learning, which is internally a field of machine learning, and machine learning is internally a part of AI. Making sense? Have I given you the bigger picture now? So for you to know NLP, you're not mandatorily need to know entire machine learning or entire deep learning, not required, entire AI, not required. You're just focusing on a set of a problem, which is on text, right? Fine, you're just working on that stream. You're just trying to solve the data problem on text. That's fine. So that's totally fine. So you're not mandatorily need to know the entire ML to learn NLP, right? So that's fine. That's totally fine, Sai. I'm happy. I'm glad that you asked this question, and I'm pretty sure that many other people will be having the similar set of question. But trust me, it's not easy to ask a question. I've been a student myself, and I'm still learning every other day, right? But still, trust me, asking a question is not easy. Speaking up is not easy. Talking to people is not easy. People don't realize that, but speaking up and asking your question is something I always encourage, and I do not get irritated or disturbed by that. So don't worry about it. Okay, so that's great, Sai. Thank you so much. Please go through the video streams, and if you feel that you have anything which you want to talk about, so anything which you don't understand, so please feel free to put up your comments. So we'll always take up your questions. Okay, great. Coming back. So I hope we answered Sai question. Coming back again. So what is my baseline of my POS tagging, guys? As I was talking about, the baseline here is my default tagger, right? So I'm just gonna say the tokens or the individual components of my the bigger expression, which is my sentence. That, hey, assign everything a particular tagger, which is noun. Okay, so that's how my default tagger is. But technically, do you think that this tagger will be valid for your entire set of sentences? No, this is not a right way to do a default tagger, right? And for each of my taggers, we can actually evaluate the tagger also. So because always remember the bigger picture here. Why we are doing all of this? We are doing all of the NLP techniques to convert the text into some sort of number, right? Ultimately, the end goal here is to convert the text to number. So because you'll be doing all of your stats, your mathematical computation on the number itself, right? You can't do anything on text. I mean, text पे आप क्या computation कर सकते हो? कुछ नहीं कर सकते हो. You have to convert everything into number, right? So whole objective behind this is to convert everything into number. So now we have a function, we have an evaluator which can actually tell you जो आपने tagging करा है for each of my tokens, how good it is, how accurate it is, right? So for that we have a functionality called as evaluate, so which is again an inbuilt functionality. So I'm not building up myself, so don't think about that. So it's an inbuilt functionality. So what it does, it basically evaluates that how good your tagging is, right? So how good you have actually assigned the right tags to individual tokens, right? So here, can you see this? So now what I've done is I've just used the tree bank corpus. Corpus basically, again, I've told you is an internal module available in NLTK. It's like where the word of sentences are already available. So like group of words available here. So I'm going to import the tree bank. Tree bank has certain sample sentences. So I'm going to use the sample sentences for my tagging purpose. So first I have tagged it. Now I have evaluated this tagger, right? So which is my default tagger of NN. And can you see this? My accuracy is only 13%. So this is very, very valid, right? So this is actually making sense also, because if I assign noun to every other token available with me, it's not going to give me the right, sense of my data, right? So it's not the right approach. So that's where accuracy is low. Now on top of this, what all taggings I can do, what all tags I can apply on, right? So now on top of this, we have something called as unigram tagger, right? So here what we do is, instead of basically having a single tagger for all of my tokens, I'm going to use individual words separately and look at the actual contextual meaning from for that word from dictionary, and based on the dictionary output, I'm going to assign the part of speech tag to that word. Got it? So here every individual word has its own individual identity. And how I'm going to do that? So basically I'm going to take that particular word, map it with the dictionary meaning, and that dictionary is actually available by default in the NLTK package. So this unigram tagger takes care of all of these things. So I'm just talking about the theoretical perspective. So it matches with the actual dictionary contextual meaning of that word and then assigns the tagging for that. Okay, so now here I'm not using even a single anything of a default tagging technique. You rather trying to give each and every word their own equal importance, right? So here, when I've applied this unigram tagger, so instead of having a default tagger earlier, I'm going to use the unigram tagger. Again, this functionality is available under my tag corpus. Okay, so tag module basically. So here the unigram tagger, I'm going to use the same set of sentences. And now when I've evaluated this unigram tagger on the test sentences, can you see this? My performance improved drastically from 13% to 89.4%. Right? I mean, technically, again, this is also making sense because default tagger does not really conceptually make sense, right? So I cannot have a single tagger for all of the available tokens, right? So I need to have the sense from the individual tokens. So I mean, for individual words has their own identity. So that's where I could see the improvement, right? Cool. Now, on top of this, we again have another a very good technique called as back-off tagging. So something called as sequential tagger. So here what I'm going to do is, now for each of my tokens, right? So the tag of that token is cascaded to its next word. So basically, now I'm going to say that the first word's a tag is actually related to my second's word tag. That is also making sense because whenever you frame up your sentences, say I am. So I cannot follow with say you, you. Does not really make sense, right? So I follows with certain word which is actually related to the first word, right? So the second was it related to my first word. So that's the concept of back-off tagging, right? So here I'm gonna cascade the previous word's tag to the next word's tag. Okay, so here the concept called as sequential back-off tagger. You can see this, the sequential. I think I have not highlighted this. Just a minute. Let me highlight it. So this is my sequential back-off tagger. So this sequential back-off tagger, this is a technique. So I'm going to cascade my previous word's tag to my next word tag. Okay. Again, it's the same logic. So I'm going to use the same unigram tagger. In fact, and I've used the back-off tagger, which is a default tagger of noun. And I'm going to pass this back-off tagger as an argument to my unigram tagger. Okay. So now it has been fed with a back-off tagger of my next subsequent word, right? And can you see this? Once I've evaluated it, The model, which was earlier 89.4%, has now further improved, although slightly, but still did improve to 90.6%. So there's an improvement of almost 1.5%, which is again a good improvement, I would say. Right? So that's the technique of a back of tagging, right? So a sequential back of tagger. Cool. On top of this, again, we have the n-gram taggers available. Right, Dhruv, exactly. This is actually used for text emotion recognition also. Yes, you have I would say an application, the text emotion recognition as well. So here, definitely we use the back of tagger. It's very important. Right? Cool. Now coming back, so the n-gram taggers, right? So n-gram basically now instead of taking one token at a time, why not take multiple tokens at a time? So maybe two words taken at a time together and then given these two words a tag, or maybe three words taken together and then trying to see what is a tag for that, right? So that's where my n-gram tagger comes. So n here means the number of tokens I want to take, and gram basically means again, it's more of a unit for token. So bigram means two tokens, trigram means three tokens at a time, and token is nothing but a word here, right? So that's what my bigram tagger or a trigram tagger does. So like the way we imported unigram tagger, I'm going to import the bigram tagger, and likewise or trigram tagger, always available in the tag module of my NLTK, right? Use the same technique, guys. I'm not doing anything. Again, I'm telling you thing very straight. Implementation of your any ML or ML or deep learning techniques into Python is not fancy. You are not doing anything fancier. What I'm doing here, just like 3-4 lines of code, right? I just imported this bigram tagger, trained it, and then tested it, and then evaluated it, right? Same set of codes, right? I'm not doing anything fancy here. So implementation is not actually very tricky, right? It's like few lines of code, very simple codes actually. But the logic behind this is what you have to understand. This is where I'm trying to put my efforts to make you understand how the concepts are, right? If you are able to understand these concepts, implementation will become very easier for you, right? So implementation is not some, see again, if you're just a machine, if you're writing this, you don't know what is bigram tagger, what is the purpose of doing this, right? So do you think you'll make any logical sense out of it? No. And there's no benefit of just running it. There's no benefit. Ultimately, you have to take a decision based on this, right? I mean, the manager won't come and ask you to run, hey, tell me what is the accuracy of a bigram tagger. They won't ask you like that, right? Ultimately, it's your job. Like after running, then now what next? How can I, take a decision based on this evaluation, and how can I take a decision so that my business is benefited? This is what you have to give, right? The manager won't tell you ki run a bigram tagger or a unigram tagger and give me the evaluation result. This is bullshit. He won't tell you to do that, right? So it depends. You have to make sense of what you are doing, and you can only make sense when you know the concepts. This is where, guys, please be very sure that implementation is not very tricky of any machine learning or data science technique. It's very simple actually, but the concepts are tricky. You have to understand the concepts better. That would be my advice to you. Cool. Coming back again. So can you see this now? So once I've implemented this unigram tagger, can you see my model performance has actually decreased? So earlier you might be thinking that, hey, maybe two words together giving me more sense. But unfortunately, the tagger is actually not giving it the better performance. It's actually giving the worse performance. And in fact, the results gone even down when I use a trigram tagger, right? So always be watchful of what are you doing. And in some cases, you might be seeing that the bigram tagger is actually performing better, right? So it totally depends on your data. So the machine learning or any technique in data science is all about your hit and trial, how you use the available data for your own good purpose, right? So be watchful of that. So that's the combination of my unigram and the bigram tagger. Now at last we have a very interesting tagger available, which is the combining tagger. So here you can actually pass all of the taggers in sequences. So you can combine the taggers, more of create an ensemble of your models, like combination of your models, combination of your taggers, and then evaluate a model, right? So here what I've done is I've created a function which is something called a back of tagger, and I'm going to pass here basically the tagger classes, the list of my tagger classes. So this is what I've done here, okay? And for each of my tagger class, can you see this? For each of my tagger classes, which is nothing but a unigram tagger or a bigram or a trigram tagger, I'm going to pass the back of. So for each of my taggers, I'm making sure that all of this is also utilizing the benefit of the back of tagging, which is eventually very good performance giving, right? So back of tagging, the cascading information of my tags, right? So can you see this? Now here I'm going to pass this all the individual taggers, the unigram, bigram and tagger, the trigram, and the back of I'm going to give the default back of tagger, which is NN, anything is fine. And can you see this? Now once I've evaluated this, this is in fact giving me the best of the lot performance, 92.35%. Making sense, guys? This is a quick yes or no, guys. So does it make sense? So we just covered the entire POS tagging again, and then I made sense. NN is not neural network here. NN here, if you're talking about this, NN is more of a noun. So it's I'm assigning a default tagger of NN, which is nothing but a noun. So this tagger is noun. So okay, let me just show it to you, this taggings. Okay, so now here you have the POS tag list, right? So you have the way you look at the list. So you have NN here, nothing but a noun or a singular noun basically here. So this is what I'm using as a default tagger. Okay, Dhruv, making sense? Okay, great. Thank you. So let's proceed. So this is about my POS tagging, guys. Very interesting topic and very important topic of my NLP technique, right? So let's try to understand our next topic, which is nothing but is parsing, right? And why it is relevant in NLP. Okay. Again, guys, this is more of a theoretical information for you, the parsing, and then I'm gonna show it to you how we can implement parsing. Implementation is again very simple, guys. So implementation में कुछ नहीं, एक function है. I'm gonna call that function. I'm gonna see the result. I'm gonna see how good it is. That's it. So nothing fancy. But what is parsing? So let's try to understand that. What is parsing, and what are the different implications of parsing, right? So the word parsing basically it comes from a Latin word parse, okay, and here with the literal meaning of the parse is getting to, draw. This is used where we are drawing the exact meaning or the dictionary meaning from the text, right? So we are trying to understand the actual literal meaning of that text from the dictionary, right? So like for example, suppose you have a sentence like give me a hot ice cream. So do you think that the ice cream can be hot? So here hot ice cream together does not really make sense, but hot individually makes sense. Ice cream individually makes sense, give individually makes sense, me individually makes sense, right? So these are individual tokens. But if we connect these tokens together, like give me hot ice cream. What is hot ice cream? There's nothing called as hot ice cream, right? So to have this kind of semantic analysis done, where I have the individual the tokens connected together, and the meaning of it is being drawn from a dictionary, that's where the parsing comes, right? So that's where the third phase of my analysis is where my parsing comes. Okay, so here basically it is a process of analyzing the strings of symbols in NLP, where we are following up the formal grammatical rules. Okay, so we are following the actual formal grammatical rules. Okay, so here we can understand the relevance of parsing in NLP with the help of following points. So parser is used to report any syntax error, where we are trying to identify whether do we have any syntactical error in my my sentences, or here how we are trying to basically understand the individual connections of my words and drawing the actual literal meaning compared to my dictionary confronts, right? So that's where the parsing is used. Okay, so I'll show it to you how exactly we implement this also. But again, parsing is of basically two major types, deep and the shallow parsing. So in the deep parsing, it's basically for more complex structures. Okay, so that's where I'm gonna parse it completely. So I'm gonna use the relationship for all the available set of relations I have available in my tokens, right? So it'll be the tree of that parsing will be deep. So it'll be having multiple sub branches in it, right? So I'm gonna draw the connections of individual words together, right? So that's where the parsing comes of deep. So it's more of a complex situation where I'm trying to understand the a complete syntactic structure of my sentences. Okay, so that's where the deep parsing comes, and it's also called as full parsing. So here again, as I said, so we are trying to understand the complete the structure of my sentence. I'm not leaving out any smaller information left out, right? But on the other side, shallow parsing is more towards we are trying to understand the limited part of my sentences, which is sufficient enough to go ahead with my task. Okay, so basically filtering out some of the textual information which might not be good depending on our understanding again. So it's basically trying to get our work done with a limited set of information and then get let's get done with that, right? So it's basically used for less complex operation, and sometimes it is also called as chunking. So the shallow parsing is also termed as chunking. Okay, so now we'll see how deep parsing and the shallow parsing can be implemented. Right. So, but before that, we have various types of parsers, right? So we have various types of parsers which can be used. Okay. So I have written 4 different types of parsers. The recursive descent parser, I have shift reduce parser, I have chart parser, and then I have regex parser. So I won't go in deep with all of these. So maybe you can come back to this video and always refer to these notes. But I'll tell you, most frequently the parsers which is the parser which is used for my the actual deep parsing is the regex parser. Okay. And now what is regex? So again, guys, I've been talking about my regex very frequently, right? So because text is all about my regular expressions. So in the regular expressions, I can provide my actual custom based rules like the regular expressions, and based on that, I can pass on my rules on top of that. So this is valid for my stemming, for my lemmatization, for my synonyms, for whatever we have done so far, right? So we always have an option of a regular expressions there. So we can always have the distinction between basically my any sort of thing. We have the default ones, and then we have use it for my own purpose. We have a question from Sapna. Is there a difference between SJ Ericason and Ericason Global? I don't understand this question, but again, I think this is not relevant, Swapnil. So maybe we can take this separately. So please, I would request to stick to our domain. So I think not a relevant question. Okay. Coming back again, so regular expressions again, as I told you. So I have written a parser here, so a very defined parser, so a very commonly used parser here. So I've used a regular expression parser, and here I'm using the concept of deep parsing. Okay, so regular expression is basically one of the technique for deep parsing. So deep parsing, again, I'm making sure that each of my individual word is giving a unique identity here, right? So that's where I'm going to use it as. So what I've done is, so this is my sentence. So again, look at this, guys. So now I'm using the already defined the POS tag of my sentences, right? So now parsing किस पे काम करता है? Parsing word works on top of my POS tags. Okay, so the input to my parsing is my POS tags basically. Okay, so here I have written a sentence like a clever fox was jumping over the wall. Right? Very plain simple sentence. So now the POS tagger has defined it in multiple different ways. So all the tags are given like DT for A, clever is JJ, my adverb, my nouns, my the verb, adverb, and then the verb here and the in, DT, and N. So all of these are different tokens given as being assigned my the actual tags for that, right? So now I'm gonna parse it. So I'm gonna call the parse function available again within my NLTK package. And then I'm going to call the actual drawings, the relationship between my individual tags. So let me just show it to you. You might not be able to see this. Just a minute. Let me capture this. Just a minute. Can I show you this? Yeah, I think you might be seeing this. Yeah. So this is how the relationship looks like now. So once I've drawn the relationship, can you see this? So what I've defined in the regular expression is use the dt, jj, and nn for my one set of functionality. So I have custom this rule and keep the others as separate. So this is my actual subject. So like was jumping over. So I've kept this as a single stream of my information, and I've kept these others like my the dt nn as my separate set of information, my another stream, so another connection, the draws of my connections, right? So this is where my things are working fine. So this is where I'm able to see that now instead of having a singular branch, the singular way where I'm observing each of these components together at one place, now I have two different set of information. So my first, the root level is my subject here, and then I have another sub level for my other component, which is like dt, jj, nn. So I'm going to define dt, jj, and nn for my individual set of information. So look at this from the Jupyter notebook. Just a minute. So yeah, this is going bad. Just a minute. I'm going to adjust this. I hope my screen is visible. Right, so coming back again for this. So this is how my regular expression I've defined. So I've defined the component for dt, jj, and nn. So anything which is falling under dt, jj, and nn, I'm going to use it for my the actual sub branches, sub streams for my the notations. Okay, so that's how I've defined it. Cool. So that's where I'm gonna define my own custom based parsers. So I can use the default deep parsers also, but I can always customize it. So I always prefer using the regular expression. So based on my custom based rules, I can define the deep parsing. So I'm going to define the relationship between my each and individual words here. So that's how it is. Cool. So now what is chunking? So chunking, as I was saying about, it's more of a shallow parsing or a weak parsing, I would say, in that sense, right? So here, where I'm not going to use each and every word of my information as howsoever it should look like. Rather, take these words as one at a time and use it for my information. So with the limited set of information I have, I'm gonna parse it and get the inter-word dependencies and the meaning, the literal meaning from a dictionary, right? So that's how I'm gonna do that. So here I'm not gonna use the entire words. I'm gonna use a limited set of words. That's where the shallow parsing and the chunking comes into picture. Certain chunks of word, basically. Okay. So now here, so I have written this again, the shallow parser here. So look at this. So I have the sample text here. So I have written the entire the sentences. So Ram being killed by Ram killed Ravan to save Sita from Lanka. And then the Legend of the Ramayana is the most popular Indian epic. A lot of movies and serials are being shot in several languages here in India based on the Ramayana, right? So just a plain simple text here. So now what I'm trying to do is I'm trying to understand the correlation between my individual words here, right? So the individual words and then how exactly these are related to each other, right? So, but again, I'm trying to focus on only a particular set of informations here. So not the entire text, okay? So now look at this. So first, as always, I've tokenized this information to kept as tokens. And then for each of my tokens, I'm going to assign the POS tag, because POS tag is the input to my the actual the chunking process. So I've defined this in the format of VB. So that's my initials for the VB. And then I'm going to pass the regular expression parser on the chungram. Basically, this chungram is my this. And then I'm going to pass the chunk parser on top of this for my parse function, right? So I've defined my regular expression parser, which is my chungram here. And now if I just draw this, again, let me show it to you. Just a minute, let me pull that up in the sheet. Just a minute. Right. So can you see this? Now everything is actually falling under my single subject, which is my S here. So everything you can see is falling under a single stream. So it's not being able to identify the equal relationship between my different words, rather taking everything at a time as a single subject. So it's not deep. So the parsing is shallow. So it's only one sub branches, not multiple sub branches, right? So that's how my definition of the chunking and the shallow parsing comes. Making sense, guys? Cool. So that's about my parsing, guys. So that's basically what I wanted to talk about parsing. It's again a plain simple logic, but again it's something which is again important to understand the literal meaning of my individual codex here. So the literal meaning of my words, right? So this is again one of the key concepts available in my NLP process. Cool. Any questions, guys? Please put up a question in the chat so we can take up, or else we can move to our last topic for the day, which is vectorization. Okay, so let's proceed. Ultimately, now we have applied all our available techniques, like हमने word nets कर लिया, हमने tokens कर लिया, tokens तो anyway mandatory है, then stemming, lemmatization, synonyms, antonyms, then we discuss about chunking, parsing, POS tagging, and then ultimately now the end goal, as I've always mentioned, we have to convert our text into numbers, right? POS tagging से भी आपका stats नहीं निकल सकता, stemming से भी stats नहीं निकल सकता, वो सब आपके mid steps हैं. Start आपका first prime step क्या है? That is your tokenization, right? And then in between you do all of these functionalities depending on your uses, depending on your requirement, and then at the very last you do vectorization. So basically this is where you actually convert your text to numbers, right? And how do you do that, right? So broadly, again, I wouldn't say that this is the only ones. There are again 2-3 more vectorizers. Broadly, these two are the most common vectorizers we use. Okay, so the count vectorizer and the TF-IDF vectorizer. So I'll take it one by one. I'll explain you what is count vectorizer, and I'll explain you what is TF-IDF vectorizer. They both are very commonly used. But look at this example below, okay? And let's try to understand this, okay? If you're not able to understand, let me know. We'll again explain that. Right. So here again we are talking about the count vectorizer, okay? So if you're not able to understand anything, just stop me. So let's try to understand few of the concept before we go towards count vectorizer. Okay, so the first is my document. Okay, so we have a concept called as a document. So a document is a single text data point, that example a product review. So basically a single text data point is called as my document. Okay, and the corpus is nothing but a collection of all these documents featured. So every unique word in the corpus is a feature. Let's say we have two documents as below. So two documents basically like this. So one sentence and the two sentence. The first sentence is dog hates a cat. It loves to go out and play. That's my first document, basically a sentence or the word on which we're trying to analyze the things. And the second is cat loves to play with a ball. We can build a corpus from, so basically this is my two individual sentences, right? So just a minute, I think this got somehow missed out. Just a minute. Right. So these are my individual two corpuses. So dog hates a cat, it loves to go out and play, and then cat loves to play with a ball. So these are my two different documents, and together they are the collection called as corpus, right? So now we can build a corpus from the above two documents just by combining it. So now here the corpus says the combination of all of this. So basically the combination of those three documents are my corpus here, right? So now in the count vectorizer, what we do is we take out the unique words from this corpus. So basically, जो भी individual text है आपका, so whatever individual text are there with you, I'm gonna first combine it, make it a corpus, and then from that corpus, I'm gonna identify the unique words out of it. So like dog, hates, cat, then A is also a word. It loves to go out and play, right? And then love is getting repeated, it'll get removed. And then I have something called as cat is again repeated, so it's gonna get removed again. So and then play is gonna remove. So this is my list of available all the words which are unique. Okay, so this is how basically it is. Making sense? And now what you're gonna do is we're gonna count the individual occurrences of my each words. So that's basically my count vectorizer. Vectorizer is as simple as that. Okay. so now look at this. So the bag of words take a document from the corpus and converts into a numeric vector by mapping each document word to the feature vector. So basically आपका feature vector क्या हो गया? ये हो गया, right? This is my feature vector. Basically my all the available set of unique words I have, which is given here. So this is my unique words on the top: and, ball, cat, dog, go, hey, hates it. So from all the available corpus, this is my available list of words. This is the actual unique words which I have. Cool. This is the unique words I have. So now for the document 2, for example, which is like cat loves to play with a ball. This is my unique. This is my document 2. So for this document 2, I can actually calculate the bag of words. So basically my individual count of my the tokens on this feature set. So now for this cat occurs here, so I'm going to give it as 1. So rest all will be 0. Click on this. So this is basically my feature, basically my column of my data set. So the and is 1 column, ball is 1 column, cat is 1 column. So this is my 1 column of all the columns of my data set, and this is my individual rows here. So where my each feature set is gonna give me the actual representation of my individual words here. So cat is being given 1 here, loves is given 1 here, and then 2 is again given 1 here. Likewise for all of the individual words. Cool. So that's my bag of words specifically for document 2. Cool. And at the end, you can see this. This is how the notation of the data looks like. So now this cat loves to play with a ball is now converted into this vector. Can you see this? Making sense, guys? So this is how we're gonna find out my count vectorizer for each of my documents, right? So likewise, we can have this document for this codec for my another document also. So here one row will be one document. So each of the documents will be now converted to a data like this. So now my text is now converted into a different vector. So basically my individual codex of my text or my numeric variable here. Right? So now look at the implementation part of it, guys. Implementation is actually very easy. Nothing fancy again, guys. Very easy. So how are we going to implement into Python? So under the sklearn, which is my scikit-learn, which is again I'm going to cover it in some time. So let's don't worry about that. So we'll take that. So scikit-learn is again a very interesting package available in Python for my machine learning part. Okay, so I'll come to that. I'll explain you that. But in scikit-learn, sklearn, in the feature extraction module, which is a text module, I have the vectorizer called as count vectorizer. Again, the function is directly available with me. Okay, so I'm just going to use that vectorizer, which is again internally doing the same logic only, which I have explained you. Okay, this is the same logic which I've explained you. So how it works? Basically, I have two documents here, the same document. Okay, so I have just first converted to make sure that there is no casing errors, because again you can see this loves is L capital, and so just if there's no casing error, I'm gonna convert this entire thing into the lower. So it's always advisable to convert the entire corpus into the lower and then start working on it. So and now to initialize my bag of words, I have initialized the count vectorizer on top of it. So this is my count vectorizer. So this is my count vectorizer. I'm gonna use the functionality fit. So I'm gonna fit the individual the corpus the documents here into the count vectorizer. So basically initializing my unique columns. This is what it is doing. So I have my unique columns here. Okay, and then I'm gonna print the feature names. So what will be my feature names? Basically my individual set of unique words. So that's what this fit is doing. Okay, so this fit is identifying my individual feature names. So individual basically the unique words available from the corpus, right? And now I'm just going to transform this count vectorizer where I have the available set of features, and then I'm going to use the document 1 on top of that, right? So that document 1, this is where I'm going to use to convert this document, which is nothing but this sentence, into the codec form of the word. You got it? So basically the numerical form of my word here. So that's it. So, and then likewise, I'm going to do it for the back of word for the second document. And now you have the representations here. You can see this. So this is my unique set of my words. So this is my unique set of my words available. So this is my feature set for my data, and then respectively the documents are being represented in the form of a text here, and in form of the numerics here. Got it? So likewise, I can just keep on appending it on the loop for all of my rows, and then I'll be having a spreadsheet, maybe a CSV file or an Excel file, where I can just convert the text into a number. So I have a number now, and then on this number I can do anything what I want, because on numbers I can perform any statistical technique which I want to perform, right? So this is one way you actually convert the text into the numbers, right? So count vectorizer. So I hope the logic is pretty much okay with everyone, right? So this is how the count vectorizer works. Cool. Right, so let's talk about the TF-IDF vectorizer now. Okay, so TF-IDF vectorizer is again very interesting vectorizer, guys, which is having some of the advancement over the count vectorizer, I would say. Right, so I'll tell you basically what is TF and what is IDF. Okay, so I'll talk about that. So we have something called as TF here, and we have something called as IDF. Right, so TF is something called as term frequency, and IDF is called as inverse document frequency. Okay, term frequency or inverse document frequency. पहले core समझाता हूँ, core है क्या? Now look at this feature set. So here you have something called as and, ball, cat, dog, go, hates, it. So there will be few conjunctions, like as you talk about, we were doing about what? So we're talking about the stop words, right? So we're talking about the stop words. So in the stop words, basically you remember we had something called as the words which are the conjunctions or something, the connectors, which might not be that, having a fruitful importance to my sentences, but they are available. And the number of times they are available are more. Like for example, I would say is, are, am, the, and, right? So these are the words which are generally repeated many times, right? And in the count vectorizer, we are counting it, the number of times it occurs, basically, right? So this one is basically the occurrence time, right? And if that particular word is occurring multiple times, that is actually not correct, right? So if you're going to say that a and these words are occurring multiple times in a sentence, this is actually not correct. So because that's gonna hamper the learning process of my model, right? So this is not correct. So this is where my TF-IDF vectorization comes into picture, and this is how it is being used, right? So I'll tell you how exactly it works. So what it does is the term frequency or the inverse document frequency gives a measure that takes the importance of a word in consideration depending on how frequently it occurs. So basically now, instead of only counting these tokens or the words, it also going to count the importance of these words. Okay, so how it does that, let's try to understand how it calculates the importance of the words, right? So to understand this TF-IDF, we have two individual components here, term frequency and the inverse document frequency. So what is term frequency? So this is basically giving you the measure of a frequency of a word in a document, okay? So basically term frequency for a word is nothing but a ratio of the number of times a word appears in the document to the total number of words in the document. So for example, suppose the number of times the word appears in the document basically divided by the total number of words in the document. So suppose I have say this, for example, I have the document cat loves to play with a ball. So here the term frequency value for the word cat would be what? 1 by 6. So I have cat is occurring only one time rather, and then I have 6 words. So the term frequency for the word cat is what? 1 by 6, right? So this is my TF. My TF of cat is 1 by 6, right? And now here, now look at this. Inverse document frequency. What is inverse document frequency? It's basically nothing but a measure of importance of the word. It measures how common a particular word is across all the document in the corpus. So basically it's trying to identify So here term frequency is looking for the number of times the word has occurred, and then in this case I'm trying to see how common that word is. So I mean, so basically for across all the corpus, across all the documents, how frequent this the word is, right? And this is nothing but a logarithmic ratio of the number of total documents to number of document with a particular word, right? So here is nothing but the logarithmic of the number of total documents divided by the number of document with the word in it. So now look at this example. So here, suppose for example, the words such as is and are like very commonly present, right? For in almost every other document, right? So now here, assume that I have 1,000 documents, okay? And out of this 1,000 document, here I'm saying that the word is actually present in all the documents, right? So I mean, technically is such a connector which is available in all the documents, right? So what it does, so 1,000 divided by 1,000, so log of 1,000 divided by 1,000 or log of 1 is 0, right? So importance of this word will be given as 0. You got it? So the term frequency will be say let's say 1 by 6, or like let's take this example of IDF only for the cat for the document 2, right? So for in this case, we have two texts, right? So the here, what is this? The dog hates a cat, it loves to play, and also the cat loves to play with the ball, right? So I have two sentences here, right? And the cat is occurring in both of these individual texts. So basically here the log of 2 divided by 2. So the number of total document is 2 and the cat is occurring in all the 2 documents. So log of 2 divided by 2 is log of 1 or 0. So in this case, the TF IDF of cat will become TF of cat multiplied by IDF of cat. So TF of cat is 1 by 6 and the IDF of cat is 0. So it will become 0. So the importance of my cat word will become 0. You got this? So this is how my TF IDF is actually extracting my data out of my individual vectorizers. So now again, the implementation is quite easy, guys. From the same feature set, I have the vectorizer available here, TF IDF vectorizer. So I'm going to use this again as the same format, the lower format of my vectorizer. I'm going to use it here. And then I'm going to fit it again the same way, use the same feature set. And then I'm going to use the feature sets on the TF IDF. And then I'm going to represent it in form of a binary format. So now can you see this? Instead of having this actual values of 101010 here, I'm going to have the representation of my documents in terms of the actual logarithmic values. So because here the TF IDF is going to give me the importances of these values. Can you see this? The same data set is now converted into the multiplication of TF and IDF of my individual words, basically. Making sense, guys? Again, a very frequently used vectorizer, TF IDF vectorizer on top of my NLP technique. So this is how we solve the problem of converting the text into the numbers. Cool, making sense, guys? So these are the two very standard vectorizers available with us. So count and the TF IDF. We have, I think, another 2 more. Again, researchers are still going on for other vectorizers also. So TF IDF is, I would say, one of the very frequently used vectorizers in our data in any NLP techniques, because the logic is very simple and logic is very good, because this is how they're using the individual components of my the tokens. So from the available corpus we have, right? Cool, guys. So anybody has any question, do let me know. I hope I was able to clarify your doubts and I hope I was able to make sense today. Right, so if anybody has any questions, guys, do let me know in the chat so we can take that. Or else if people are good, so we can maybe wind up the session. So we are pretty much good for the day. So we have covered everything, whatever we wanted to cover today. And we are now, we have done everything from the NLP functions perspective. So we have that sorted. Right. So now what we can do is maybe we can solve a live problem, and maybe let's have that sorted also. So we can solve that problem. So we can have a live run through of all the available set of functionalities, and then we can have it solved together. Right, so we'll see that maybe tomorrow. Right, so with this, guys, I'm pretty much done. This is what I wanted to cover in the NLP functionality. So we are done with the NLP set of functions. So this is how my NLP is. So this is the, I would say, the core functionality is available within my NLPs, and I've added everything to the best of my knowledge. I might have missed few other topics, but again, whatever I might have missed, so might not be that of mandatory requirement to be covered off. So these are my core structure of NLP. So that's how we are building up the NLP feature sets. Cool, guys. So with this, let's wrap up. We're done with the NLP function. So maybe we can do a quick summarization someday. So we can just run through my entire topic. So just to connect the dots, and then we can start working on the live demo. So we can do that. Cool. So with this, guys, thank you so much. And thank you so much for being patient and listening to me on this. So we'll wind up for the day, and maybe again, let's see each other tomorrow, 10 p.m. same time, and then we can see from where we can proceed with that. Great. Thank you so much, guys. Thank you so much, and wish you a good evening ahead, and happy learning. Bye bye.